So the first type of distortion we're going to cover is linear distortion. So linear distortion can occur via amplitude distortion, phase distortion, or you could have both types of distortion at the same time. Let's take a look at what it might mean to have linear distortion in your communication channel. Let's imagine that you have some kind of triangular pulse that you're sending, and below A, this pulse is equal to 0, and above B, the pulse is equal to 0, and then in between it's some kind of triangular shape. So your definition of this looks like this, and if your pulse, g of t, passes through a system that has linear distortion, what may occur to this pulse is that there will be both an amplitude change and a time delay. So let's see how that might look if you have amplitude changes and time delay changes. If that were to occur, then some of your signal, g of t, would spread beyond that bound of A and B when it reaches your receiver, compared with some reference time 0. And so this might look something like this. This is a bit of a crude drawing, but basically you can see that below A and above B, right, you now have some gap, right? This is some change in g of t that's occurred due to the spreading of that pulse. This spreading out of the pulse and changing in amplitude is called dispersion. So this is a type of distortion that can occur in a communication channel. This type of distortion can be particularly harmful if you're trying to send things like multiple pulses that you will later try to interpret. So if you had two pulses that were sent through a channel with that caused a dispersion, you might have a spreading out of these pulses to the point where they may start to mix together, and you can no longer, at your receiver may no longer be able to tell the difference between the two pulses. This leads to a very high risk of detection error at your receiver.